Assalamualaikum warahmatullahi wabarakatuh, and greetings to everyone, especially to our lecturers, Dr. Safar bin Ahmad. So today, me, Nur Akila Syahira Mrumah Azhar, Mithalina Safia bin Muhammad Sotali, and Ami Batrisha binti Anwar will be presenting our CSC649 final project with the proposed title of Mrumah, an AI-powered property recommendation system with conversational chatbot for Malaysian home seekers. First of all, problem identification and motivation. So firstly, problem statement. Ideally, Malaysian home seekers should be able to quickly find rental properties matching their preferences, budget and lifestyle needs. But in reality, most property portals offer only static listings and basic keyword search with no personalization or guided support. So this leads to inefficient, frustrating search, longer decision times, and missed opportunities, which is what Mrumah try to address, which is by integrating a personalized matching engine, swipe-based discovery and interactive map, and an AI-powered conversational chatbot. So what is the project objective? First of all, is to design a personalized property recommendation engines that match Malaysian rental listings to users' preferences based on lifestyle, commute, and budget criteria. Second is to develop a web-based platform incorporating swipe-based property discovery and interactive map view and passive listing features to support efficient and engaging property search. And lastly, the third one is to design and integrate an AI-powered conversational chatbot capable of understanding natural language queries, recommending properties, and providing relevant property information to users. And the next one is the project significance, which is first is the personalized matching engine reduces time effort to find suitable rentals. Next is conversational chatbot plus with the swipe interfaces to improve guided search experience. And the last one is contributes the practical PropTech application of recommendation system with conversational AI. Moving on to the literature review and understanding. First, overview of online property search. Property portals replace classified ads or physical viewings with searchable digital listings. Many portals use structured filters, and these filters work only when the users already know what they want. This step motivates recommendation systems and conversational interfaces. First is the filter-based search. It works on Boolean and range logic, so you might say price between 1,000 and 2,000 and at least 2 bedrooms. The system checks these conditions against a static database and returns matches. The problem is everyone who sets the same filters get the same exact list. It doesn't matter if one person really cares about being pet friendly and another cares about the furnishing. The system treats them identically. Next is the swipe-based and preference-aware discovery. The idea is simple. You are shown one option at a time and you either accept it or reject it. Swipe right or swipe left, each decision becomes an implicit signal about what you actually like even if you never explicitly said so. Next, the overview of enabling technologies. First of all is the recommendation engines. A recommendation system estimates how well an item fits in a user's preferences and ranks candidates accordingly. It divided to two families, which is the first one, collaborative filtering, that infers preferences from other users' behavior. It needs large historical data and suffers from cold starts for new users. Second is the content-based or rule-based scoring that ranks items by comparing attributes directly against stated preferences. It needs no historical data and results are explainable. Second is the conversational AI and LLMs. The key capability is the function calling. The model is given defined functions such as property search and decides which to invoke with arguments extracted from natural language without a custom-trained NLU model per query type. Moving on, the research gap comparison of existing application, which is the smart house renting app, and Ensemble with the proposed project, which is the Mrumah. Now we will consider 5 features, which is structured filters, personalized scoring, conversational search, explainable ranking, and consistency across interfaces. Now the first features, which is the structured features, the smart house renting app only apply keywords or location, while Ensemble apply filters of budget and location. And Mrumah apply location, budget, size, and amenities to the filters. Second, personalized scoring. Smart house renting app and Ensemble does not apply the personalized scoring, while Mrumah apply it by implementing the location by 25%, budget by 30%, size by 20%, and amenities 25%. Third, the conversational search. Again, Smart House Renting app and Ensemble does not apply this conversational search, while Mrumah apply it by implementing Nestbot and using LLM's function calling. Fourth, the explainable ranking. Again, Smart House Renting app and Ensemble does not apply the explainable ranking, but Mrumah apply it by broken down certain components. Lastly, the fifth features, which is the consistency across interfaces. Now, Smart House Renting app doesn't apply this, but Ensemble apply it in single interfaces only, while Mrumah apply the consistency across the Discover, Map, and Nestbot. going to present our proposed solution, which is Mrumah, that simplify the rental shoes process through 4 components, which is the first one is intelligent web-based platform. It's developed using HTML5, CSS3, and JavaScript for a modern, responsive user experience. And then we integrate leaflet.js to provide real-time interactive map visualization of listing. The second one is preference-aware recommendation engine. We generate instant compatibility match scores based on user lifestyle and budget. We use a lightweight structured JSON dataset, which we name it as listing.json, targeting major Malaysian city. And then the third one is conversational AI, which we call it as Nestbot. It's powered by the Grok API to offer natural language interactive directly inside the apps and deliver conventional answer alongside visually ranked property card. And the fourth one is NLP intent and action classification. We utilize function call to understand and classify user queries in real time and automatically identify key user actions such as searching, comparing, and serving properties. Moving on to our system architecture, we adopt the model view controller MVC design pattern to ensure modularity and maintainability. At the view layer, our single page template NestMesh.html handle the front-end chat interface and property card displays. For the controller piece, chat controller.python manage all interaction, intercepting client HTTP requests, enrich user content, orchestrating Grok API calls, and rendering final HTML. At the model layer, property model read data from our structured listing.json database. It hosts our shared scoring logic, enforcing location at 25%, budget at 30%, size at 20%, and amenities at 25% to ensure data consistency across the entire platform. Our technical implementation focuses on conversational intelligence and mathematical precision. For conversational AI, we use Grok function calling to translate raw text queries into direct back-end operation, just listing, compare listing, or self-listing. The back-end also automatically injects self-user preference as default parameter when details are omitted. For our conversational method, we ensure cross-platform consistency by running the exact same mat on both Python and JavaScript. We enforce a hard location filter first. Properties outside the user's target city are excluded before the engine calculates our wage formula, which is match score equal to 0.25L plus 0.30B plus 0.20S plus 2.25A, which is L is for location, B is for budget, S is for size, layout of the house, and A is for amenities. And this guarantee mathematically sounds highly relevant result. Next, our feasibility and planning. We design a highly optimized dataset and feature structure. To ensure sub-millisecond query latency, we structure our data locally inside listing.json instead of using a heavy database. Our dataset covers 12 curated listings across 9 Malaysian areas as shown in property dataset scheme. Each listing is structured with clear type for each field and also description. And then this scheme field map directly to the capture preference extract from user conversation, ensure accurate and error-free filtering. For target modeling, Mrumah generates a continuous match score from 1% to 99%. We generate a compatibility rating representing how well a property listing fit the user's specific preference. Our approach is expandable and transparent, showing users a clear dimensional drop-down so they know exactly why a property is recommended. And a key design decision here, why did we choose a rule-based approach over machine learning? So first is no ground truth. A real-world rental data lag doublet historical data like rented, PS not rented, so we need required to train a supervised classifier. Second is bypass cold start issues. New user receive highly accurate portability recommendation instantly on day 1 without waiting for model training. So next is for flowchart. For flowchart, once user enter the system, it will display the dashboard and then it will show the next board and also the discover button, map button, save button, and also the profile button. And then if user want to chat with the dashboard, if user need to send a message, and then it will send the HTTP post request to the chat route post in controller, and the controller will trigger AI service handler function to Grok, and the Grok API will decide whether it needs a property to call or not. If no, Grok will generate a standard casual text response, and if yes, the model interaction function will call property model, and it will read the listing JSON database, and then the score listing function will calculate the weight, and lastly it will view process final message response and property card layout, and it will show the chat user interface to the user. And then if the user want to see the discover page, we display general listing, and if they want to see the map page, we display property location on map module. If they want to see the save page, we display user's bookmark properties, and user want to see the profile page, we display user profile data.
Based on this figure, it illustrates the main recommendation interface for Mrumah. The system display rental listing together with their responding match percentages. The recommendation score is further decomposed into location, budget, size, or amenity subscores to improve transparency and explainability. As for this figure, it demonstrates the natural language processing capability of Nestbot. The chatbot successfully interprets the user's budget and location requirements and generates an appropriate rental recommendation together with an explanation of the selection. As for this figure, it shows the recommendation engine ranking multiple properties according to the calculated match percentages. This enables user to quickly identify the most suitable rental option based on their preferences and constraints. Next, I will demonstrate the main feature of Mrumah. This is the main feature of the system. The user can browse available rental opportunities and view details information such as price, location, number of bedrooms, amenities, and match percentage. Unlike traditional rental platforms, Mrumah provides expandable recommendations by breaking down the overall match score into location, budget, size, and amenity scores, allowing users to better understand why a property was recommended. Next, the first demonstration shows the conversational AI feature of Nestbot. Instead of manually selecting filters, user can simply describe their preferences using natural language. In this example, the user requests a rental property in Ipoh with a budget below 1,500 ringgit. The Nestbot successfully extract the location and budget requirement and return Ipoh Riverside home as the recommended result. The chatbot also explains why the property was selected, improving recommendation transparency and user trust. Next, we demonstrate the recommendation engine using more detailed requirements. The user requests houses with at least 3 bedrooms and a maximum budget of 3,000 ringgit. The system evaluates all available properties and ranks them according to their match percentages. Properties that better satisfy the user's preferences receive higher scores and are displayed at the top of the recommendation list. This allows users to quickly compare multiple options and make more informed rental decisions. The chatbot is also capable of handling border location-based searches. In this example, Nestbot identifies multiple properties located in Kedah and returns them to the user. This demonstrates the chatbot's ability to understand location entities and provide personalized recommendation using conversational interaction. Now let's move to the limitation. The current prototype uses a small dataset of only 12 listings, which is sufficient to validate the recommendation logic, but insufficient for evaluating performance on large-scale property databases. Additionally, the chatbot relies on the Grok API, making the system dependent on internet connectivity and third-party service availability. Finally, the recommendation engine uses manually defined weights rather than a machine learning model trained on user interaction data. For the future improvement, which include expanding the property catalog using live data sources and evaluating the chatbot using benchmark datasets to measure extraction accuracy, the recommendation engine could also be enhanced using user feedback such as safe listing or swipe behavior to automatically adjust recommendation weights. Additionally, features such as user accounts and direct communication with property owners would further improve the platform's practicality. Overall, Mrumah successfully combines recommendation systems, conversational AI, natural language processing, and generative AI to create a more efficient and personalized rental search experience. That's all from our group. Thank you for watching and have a nice day.